Very interesting question, this one, children. Very good one. What it says: find the coordinates of the point of trisection, means dividing into 3 equal parts, of the line segment AB with A known to us, B known to us. Means the coordinates of A is given to us and coordinate of B is also given to us. What you need to find out? That this particular AB is being trisected by 2 points. How do you know, sir? 2 points? Let's see. Let's see. By drawing the diagram, let us understand. By drawing the diagram, let us understand. This is my A, this is my B. A coordinate is 2, 7, and that of B -4, -8. B is -4, -8. Now they say we intend to find the coordinates of point of trisection. So let me make use of different marker to make you understand. Point of trisection means divides into 3 equal parts. So how many points can divide AB into 3 equal parts? There will be 2 such points. So point P, point Q. Point P, point Q. We need to find out the coordinates of these points. So if this were to be my x1, y1, x2, y2, this will be x3, y3. That of this will be x4, y4. I hope my children are getting it. Now, question arises that when they say trisection, do we really mean what? We mean that AP is equals to PQ is equals to QB. All 3 of them are equal. Now, how to find out the coordinate of point P and Q? Answer is very simple, children. So try and understand. Via this sum, I'm going to make you understand 2 more sums within the same question, so that we won't be solving those kind of sums which I'll be making you. But first, let us understand this. Once we are done with this, I shall give you 2 more questions within the same sum and brief you the answer also. Right? So, we got to know that A and B are the 2 extreme points of segment AB. P and Q divides AB into 3 equal parts. We intend to find out the coordinates of point P and that of Q. So, very first understanding, what do I get is that since AP is equals to PQ is equals to QB, as being stated from their side trisected, can I say that point P, when I just pick up point P into account, forget about point Q as of now, forget about point Q. Can I say point P divides AB in the ratio 1 is to 2? When I say 1, I'm talking about AP. When I say 2, I'm talking about PB. I'm talking about PB, mind you. So can I say point P divides AB in the ratio 1 is to 2? Can I? Certainly yes. Certainly yes. Maybe some other child may say that, sir, you went for point P and you said the ratio is 1 is to 2. I can say for point Q, the ratio is 2 is to 1. If I pick up Q, then the ratio is A to Q is 2 and Q to B is 1. That's also correct. That is also correct, children. Are you getting me? I picked up point P. The ratio is 1 is to 2. Some other child might say, sir, I'm picking point Q. Isn't the ratio going to be 2 is to 1? Perfectly correct, children. Choice is yours, call is yours. Right? I shall pick up point P, ratio 1 is to 2. And when I have ratio, whom should I call down? Whom should I call means? Which formula should I make use of? Section formula. When I have a ratio, we should make use of section formula. So, what is it? First, for point P. But before that, we write down the solution as let A having coordinate 2, 7, x1, y1, that of B -4, -8, which is x2, y2. Let P with x3, y3, x3, y3 and Q x4, y4 divides segment AB into 3 equal parts. Divides AB into 3 equal parts. Now for point P. Now, point P divides segment AB in the ratio. What ratio does it divide AB in? In 1:2. And I have made you understand. The blue marker says, the blue ink says 1:2. You could have taken 2:1 also, but that will be in context to point Q. We are taking and picking a point P by using section formula for internal division. Fine. By using section formula, what? X3, coordinate of this X3, my M is 1, N is 2. If you want, you can write down that is M is to N is 1:2. My M is 1, N is 2. So what is that going to be? X3 is MX2 plus NX1 upon M plus N. Likewise, what is my Y3 going to be? MY2 plus NY1 upon M plus N. Children, any problem? Right? X3, M, which is 1, X2, which is -4, N, which is 2, X1, which is 2, upon 1 plus 2. Let me solve this first. -4 plus 4 by 3, X3 is 0 by 3, X3 turns out to be 0. What is Y3? M, which is 1, Y2, -8, N, which is 2, Y1, 7, M plus N, 1 plus 2. So Y3 is -8 plus 14 by 3, Y3, 6 by 3, Y3 is 2. So what did I get? The coordinate of point P as? I got the coordinate of point P as 0, 2. Let me jot down that here. Let me write down this here. So we got the coordinate of point P. Let us write down that also. Therefore, the coordinate of point P, which is x3, y3, which is 0, 2. I hope my children are understanding this. Right? Now, there are many who will say, sir, we already have the answer for point Q. We'll take the ratio as 2:1. Absolutely correct. Absolutely correct. But why will I go and once again make use of section formula and make my sum lengthy? And calculations are more in section formula. But if I ignore this part and if I just take only PB into account, children, kindly pay attention. We are not making use of section formula. We are not making use of section formula. So ignore this part and just understand that we have only PB. Don't you think so? That point Q shall act as a midpoint. Ignore this. What is there in your vision? PB. Since PQ is equals to QB, is Q the midpoint? Indeed. P, just now we got it. B, already we have it. Can't we make use of midpoint formula to get Q? Those who want, I shall make you understand. Take this P, take this as B. This is P with Q. P just now you got to know. B is what is given to us. PQ is equals to QB. Can't I make use of midpoint formula to get this one? Absolutely yes. So we are not making use of section formula once again. We are making use of midpoint formula for segment PB. So we write down our answer as, after this, we write down our answer as, for segment PB, for segment PB, point Q, whose coordinates are x4, y4, is the midpoint of PB. Therefore, by using midpoint, I'm writing shortcut formula, by using midpoint formula, what? The x4 is going to be x3 plus x2 by 2. Our P is x3, y3, our Q is, our B is x2, y2. So x4 is x3 plus x2 by 2, a slight modification in the formula, and y4 is y3 plus y2 by 2, mind you. What is x4? x3, we just now got it, 0. What is x2? We have minus 4. So 0 plus of minus 4 will give me minus 4 by 2. Let us solve this. Minus 4 by 2, which is minus 2. That's x4. How about here? y4 is y3. Here is what we have, 2. So 2 plus y2. How much is it? Minus 8. So plus of minus 8 will give me minus 8. I'm writing it directly. By 2. y4 is minus 6 by 2. y4 is minus 3. So what is the coordinate of point Q? Therefore, the coordinate of point Q is minus 2, minus 3. The coordinate of point Q is minus 2, minus 3. As simple as that, children. I hope my children are getting it. So we are done with this particular sum. When they say, find the coordinate of trisection of line segment. What did we do so? We first picked up P. When we know that AP is equal to PQ is equal to QB, for point P, it divides AB in the ratio 1:2. Thereafter, we picked up PB and said Q can be found out by using midpoint formula and not by making use of section formula once again. It shortens down our calculation. More of the calculation is very, very simple compared to the section formula. Right, children? But I said in my starting of the question that via this sum, I'm going to make you understand 2 more sums. So let me make you understand 2 more sums. Let me make you understand 2 more sums, and my 2 sums are here, explained here. Mind you, this is something extra, children. This is something extra. And I'm explaining you 2 more sums. What if here, instead of they say trisection, they say divide into 5 equal parts? What if they say divide into 5 equal parts? So let me draw the diagram for the same. So first I'm saying here, extra question, 5 equal parts. So how the diagram will look like? When we had 3 equal parts, how many points we wanted, or how many points did we took? 2. When we have 5 equal parts, how many points we shall take? 4. So let me say P, Q, R, S. Can I say that these are equal? Again, the question will be the same. What? You will be given the coordinate of point A. You will be given the coordinate of point B. And I'm supposed to find out the coordinates of P, Q, R, S. Concept remains the same. What? I'll pick up first P. For P, the ratio will be, this is 1 and this is going to be 4. So I shall find out P by making use of section formula, absolutely on the same line. Here also for point P, we made use of section formula. Here also for point P, I shall make use of section formula. The difference was, or rather the difference is, here the ratio is 1:2. Here we will have to take 1:4. Once we get point P, children, once we get point P, ignore this part. Now just take PB. Just take PB. What do you think so? PQ is equal to QR is equal to RS equals to SB. Don't you think so that for segment PB, isn't my R going to be the midpoint? For PB, R will be the midpoint. After using section formula and obtaining coordinate of point P, can't I get coordinate of R by using midpoint formula? Indeed, yes. So, with help of midpoint formula, I shall get coordinate of point R. Thereafter, ignore this portion and just focus on just focus on PR. With P known, R known, can't I get via midpoint? On the same lines, with R known to us, B already given to us, is S the midpoint? Indeed, by midpoint. So what did we learn, children? What I wanted you people to learn, when there was trisection, that means 3 equal parts, 2 points, first point by section, second one by midpoint. So we are making use of one section, we are making use of one midpoint. When there are 5 equal parts, we are making use of section and then QRS, all the subsequent ones by midpoint, by taking different segments. For PB, R is a midpoint. For PR, Q is a midpoint. For RB, S is a midpoint. So how many midpoint formulas did we make use of? 3 times. And how many section formula? Once. Right, children? So one is trisection, one is into 5 equal parts, and one more question. What if the question says 4 equal parts? I'm writing with different markers so that you can distinguish also. This was 3 equal parts, 5 equal parts, now comes 4 equal parts. Answer is, so when I say 4 equal parts, how many points will be there in between? 3, AB, 4 equal parts, so P, Q, R, all of them are equal. All of them are equal. Now again, there are many, not all. There are many, not all. Will again say, sir, no children, I'm not going to make use of section formula this time. I'm not going to make use of section formula. Sir, you did in 3, you did in 5, you are not going to do in the 4th one. That is in 4 equal parts. You can, mind you, you can by saying the same concept. For point P, 1:3. But no. Since A being known to us, B being known to us, that will be given to you, mind you. With AB, don't you think so that Q acts as my midpoint? I can make use of, or rather I shall make use of midpoint formula and get the coordinate of point Q. Once I know the coordinate of point Q, for AQ, P is a midpoint, again by midpoint formula. For QB, R is a midpoint, again by midpoint formula. So there is no section formula coming. Midpoint, midpoint, midpoint. So what is the central idea of the entire 7, 8, 9 minute sum? What is the central idea of a 10-minute sum, what we have done, along with 2 extra questions? The moral of the story, central idea is that if the division is in odd numbers, 3 equal parts, 5 equal parts, say for that matter 7 equal parts, which is not going to come, 7 equal parts will never come, we make use of one section, others midpoint. One section, others midpoint. And when we have even equal parts, 2, 4, 6, again 6 will are likely chances very less. 2, 4, and I'm just saying even parts, we won't ask section formula to come. We can solve all of them and find the coordinates by making use of midpoint formula. So what is the central idea? If odd equal parts, one section and others by midpoint, and even equal parts, all of them by midpoint, children. Right? So via one sum, we have solved 3 main questions actually.